Hello girls and guys, ladies and gentlemen, welcome back to Robothought Zero to Hero series Vision Intelligence using Jetson Nano. Alright guys, so we are on lesson number 10 today and I am going to show you how to do some coding on Python to execute your object detection models, right? In all the previous chapters, I hope you guys have installed all the utility tools and the libraries. I showed you the Python open source libraries, how to install and configure on your Jetson Nano, and I hope you are done with that, guys. And I'm really hoping to see some examples from you guys and show me some of your videos and exercises. All right, guys. So in this lesson, I will show you how to execute those pre-trained models. That is your, there are 10 different models which you would have seen in the screen, in the terminal screen when you are trying to configure all those commands which I showed you, right? So those models, how do you run it? How do you visualize it, right? How do you visualize using the camera and detect the object and show it to you on your screen or even on a mobile, right? It's possible. I tried on my mobile. Connecting remotely. That's a little advanced lessons. I'm going to take it for the future. Okay, so let's do some coding, and guys, I will try to explain line by line, but it's not practically possible because that's going to drag this session for about several hours. So what I'm going to do is I'll quickly code it and I'll run it and show it to you, and I will leave the entire set of code, the source code, in the description below. All right, and also my GitHub link, which is already available. So all right guys, let's get into some interesting aspects. Let me get into my Jetson Nano and I need to open up my IDE. All right, I am already there. Okay guys, I hope you have installed the Visual Studio Code, which I showed you how to install and configure and set up. It's pretty simple, anybody can do that. And once you are there, once you are ready with your Python interpreter which installed into your IDE and configured for Python 3.7 or 3.8, what you need to do is create a folder, create any name. I had created a folder on my Jetson Nano desktop called object detection, and you need to go to file and open the folder. So the folder is, say, object detection. There is nothing in this folder, so select. All right, now if you go to this folder, there's nothing, there is no Python scripts or Python file inside. So we are going to create something from the scratch. All right guys, so can you see here, you can see new file and new folder. If you click new folder, you will create a subfolder within the main folder, object detection folder. Okay, so I'm going to create a file. Basically we need to create a Python file. Okay, let's create. So the name of the file can be object, caps lock, object detect. Guys, make sure the Python file should always end with .py. Okay, I hope by this time you would have got hands-on through my previous lessons which I showed you, the previous sessions on Python, using Python scripts on Python on Linux terminal. So in that lessons we created tons of Python files, right? So it's the same way, object detect .py. All right, and you need to hit enter and you are into the script. All right, now first thing what we need to do is we need to import our Jetson Inference library, the entire package which we already installed in our Jetson Nano. So let's import Jetson.inference. All right, enter, and then we need to import the tools, the utility tools called utils, which we install. I showed you how to install it. Import Jetson.utils. All right, and then we need to import time. I'll tell you in detail what exactly is that. Import time, and then we need to import our OpenCV. What is the keyword for OpenCV? Yeah, it's CV2. It's not OpenCV, right? It's CV2. There you go. You can see the pop-up message. CV2, and then we will also import NumPy as NP. All right. Okay. Now what we will do is, timestamp. Let's create a timestamp. Timestamp equal to time.time, and this is a function, so we got to open and close the parentheses. So basically, guys, this timestamp function, it's basically, it will return the number of seconds or number of minutes it takes to pass a particular epoch of data, right? The data which is flowing through your camera capture, and that gets into your pre-trained neural network, and this particular the time.time function basically takes the data from your camera and inputs into your neural network, and then translates into a human readable kind of a string value according to your system machine local time, which is fixed in your Jetson Nano's machine, right? So it will throw up that particular string, and this function is very important. You will know how to do that in the later stage. I'll show you some more details. And then we will also calculate frames per second, that is FPS, and then we need to filter it and set it to say 0. So we are basically setting the frames per second with a pass-through filter to 0. Okay, now let's say which is the net. Now we need to tell Python what network we are going to run, what neural network we are going to run. So let's say net equal to Jetson dot inference. Let me scroll it. Jetson dot inference. There you go. You can see Jetson dot inference, and detect net, and you can select, you can in this open and close parenthesis with a single quote, you can put any of the neural network which you actually downloaded. I think there were about 10-15 neural networks which you would have downloaded, right? In that screen which you saw while installing all those libraries. So you can put any one of them or two of them or 10 of them, but all the 10 will not run together. You got to execute one by one. Okay, keep that in mind, guys. So I'll say SSD mobile net V2, let's say V2, comma, and we need to set a threshold, right? Threshold equal to say 0.05 0.5. all right, so this will, so in this particular line you are telling Python to grab that particular neural network, that is your SSD mobile net version 2, right, and then run the inferencing. Okay, now let's move on to the next. Okay, so now we need to set, we are importing the inference, and then we need to set the size of the dimension of your window, right? And that will purely depend upon what camera you are using, guys. So in case if you are using Logitech C310 or 270, go for 640 by 480. That is the width will be 640 and the height will be 480, right? So it will form a proper window on your screen. Let's define that. Say display width equal to 640, and then display height equals to 480. All right, now let's also define a flip. So this flip method basically, you can set it to say 0 or 1 or 2. So what happens is, you can turn the cam. This actually works for your Raspberry Pi camera, not for USB cam. So I would suggest you stick with flip 2 because that's a standard dimension which will show up. But for Raspberry cam, you tilt the camera and your image will tilt, and it's little cumbersome and tons of errors you will face in that. So I suggest stick with USB camera and stick with flip 2. All right, and then let's define a font equal to CV2, which we are importing. Font 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 equal to, we will import the fonts from OpenCV dot in uppercase font underscore Hershey underscore simplex. Ideally the drop down, it should automatically populate. Probably my ID is not configured with the interpreter properly I guess, so sometimes it happens. But just remember, this is just to set your font. There are tons of other fonts which are available, which you can use it as per your choice. And then we will start capturing the camera. So let's say cam equal to what did we set it as? Cam equal to CV2 dot video capture. Okay, there you go, video capture. And then the path for the USB camera, if you guys are using USB camera, make sure that it's defined as 0. If you are using say a Raspberry Pi camera, there's a separate string for that, and I'm going to show you at a later stage what is that string. But for USB, this is the particular string we'll be using, and this is the path. Say /dev/video 0. Okay, in any of the 4 USB port you can just plug in, okay, which is there in your Jetson Nano. And then we will say cam dot set CV2 dot cap underscore, I hope I get this, prop. There you go, there are tons of prop underscore frame underscore width comma display width. All right, let me scroll it down. All right, I hope you guys can see the screen properly. And then again we need to cam dot set. We need to do the same thing for height of your window, the image capturing. And then CV2 dot cap underscore prop. We can just copy paste the same thing as above and put it as display, but anyways, I'll just copy and paste this. All right, that will make things more simple. Copy and then paste, and here we need to put display height instead of W, uppercase height. There you go. All right, and then what we need to do, we need to, once the image is captured through your video, we need to say what it is supposed to do, right? What if it will do continuously. So how do we do that? We need to bring this into the while loop. Okay, now let's say while true, while the above is true, colon, indentation, guys, very important. Okay, underscore img underscore comma img. Okay, import warning, it's fine, that's fine, equal to cam dot read. So we are setting a function to read the camera frame, and then we need to assign a height equal to img dot shape, and then set the shape into your tuple, which can be 0, and then set the width equal to img dot shape, and this tuple can be say 1. Okay, and then say frame, let me just give a line in between, let me scroll it, frame equal to cv2 dot cvt color. Now let's set a color. Okay, img comma cv2 dot color underscore blue green red bgr. Remember guys, you are converting bgr to rgba, right? That's how the OpenCV system works. bgr to rgba. Okay, there you go, automatically you can get that. Dot as type, and then put it into your numpy array np.float 32. All right, I'll get into the details guys at a later stage. I'll explain what exactly this means. And then frame equals to np as I messed it up, as type np array np dot float 32, and then close the parenthesis, enter, come into the next line, frame equal to jetson dot utils dot CUDA from numpy array, and then create a frame. Okay guys, it's very simple, logically you can understand the sequence, right? And now what we are going to do with that array is, once you capture that from the frame, you need to create the detection. All right, equal to net dot detect, and what to detect? It's the frame and the width and the height. All right, and then once the camera detects that, in this we need to create another loop. So what is that? It's going to be for loop for detect in detections. Right, now we need to set certain class, right? I taught you what a class is, a class ID means, and the class means in Python tutorial. I hope you had seen those lessons guys, so try to understand what those classes are, how to define a class. For every object you need to define a class, all right, and a class ID. So I'll show you how. ID equal to detect dot class ID. All right, now from the top equals to detect dot top, yeah, correct, and then left equals to detect dot left. All right, and then we need to set the bottom parameters, that is bottom equal to detect dot bottom, and then on the right side, right equal to detect dot right, and then we need to set another class ID called item ID. Item is net dot get class description ID. I'll just put it in short. Yep, there you go. All right, and then we will print it out. Print, what do you have to print? Item plus top comma left comma bottom, and then right. Okay, now Now what we need to be doing is basically, I think we are almost there. So we have set the left, bottom and right. We can also put a date and time. Okay, let's come out of this loop. Okay guys, just notice the indentation. I just came out of the for loop. Okay, I was within the for loop, now I came out. I'll just put a date and time function, which is dt equals time, close the function, and then time minus timestamp. Yeah, timestamp, there you go. And then timestamp equals to time. Okay, and then we need to end the function here, and then we'll call the frames per second again. Frames per second equals to 1 divided by the date and time function. Okay, all right, now frames filtration, frames fill, okay, equal to 0.9 into fps fill, frames per second filtered again, plus 0.1 into frames per second. Right, I hope this calculation is correct. I'll tell you how it works, guys. And then again we need to get back into OpenCV, that is CV2. Yeah, let's say CV2 dot. Now what we need to do is we need to put a text. For example, you are turning the camera into, say, a keyboard or a mouse or any other object. All this above code is going to detect, it's going to detect and identify what it is. Right now you need to put a text, what exactly is that, so that will grab that text. It's going to match with your pre-trained neural network and send you the correct stuff. Right now let's see, cv2 dot put text img comma, and then we'll create a string in this round, and then another open and close bracket with your fps. Okay, filter your bypass filter, and then set it to 1, and then come out of that. Okay, let's say let's say plus, and then put the string again fps, okay, outside the string, comma, and then you set the size 30. Okay, and then we will also set a font comma 1 and then we will also set the color. Okay, 0 comma 255. So we'll set it to this particular color, and then the density, the thickness of that, maybe 1, I think it will become too small, say 2. Right, and then cv2 dot, we are going to show that show. Okay, what we will show what we designed at the beginning. Right, what did we declare as detect cam? You can just name it anything you want, guys. Whatever the name you are declaring, make sure that you follow the same name. Okay, detect cam, and then what do we detect? It's your image. Okay, and then cv2 dot move the window to a corner of the screen, or else it will just randomly, it will show up on your if you are using a laptop or or if you're whatever the size of the monitor you are connected to Jetson Nano, if it is too big, it might randomly show up in the middle or somewhere else. So best thing is to set it in one single corner, and that will be typically your 0, or let me show you, move window, and then you need to move the detection cam to 0, 0. All right. Oops. Detect cam. 1 second. There is a mistake. Yeah, 0, 0. All right. Now what we need to do? We need to set a parameter to kill the window, right? You just cannot kill the program, or you just cannot close the IDE. That will just crash your Jetson Nano, and it might catch up on some of the memory stuff. That will create some other problem. So we got to close the camera window. How do we do that? If cv2 dot wait key is 1 equal to odd of, say, any key A. No, let's say Q for quit. Let's set it to Q. So if you press the Q in your keyboard, it will just quit. Your window will come out, and then colon, okay, and then break. Right, guys, I hope you understood this. I also taught you about the break statements, and then we have to release the camera. You need to come out of this break loop. Cam dot release, open and close parenthesis. Let's see, 46 lines of code. I hope we haven't done any mistake. Let's run and see. I hope it works. Alright guys, so let me just connect my camera, and then we will try to run it. Okay, I think it should be fine. Hopefully it should work. Give me a second, guys. I'll just connect my camera to my Jetson Nano, and then we should be, I think it should be fine. Alright, now let's try to execute. Let's see. Yeah, I think it should work, guys. I don't see any issue. Hopefully it should work. Okay. Alright, so we are ready for the magic. Let's run this code and see. I hope it works. So let me just check it up. Give me a second. And I will add a mouse, extra mouse. I need to set up my camera so that you guys can see the objects around. Alright, now let me just run this program. Let's just right click. What's happening? Oops. Right click, run Python file on terminal. God knows how many error is gonna show up. Hopefully it runs. Yeah, my camera is activated. There you go, guys. Boom. So it's showing 14 fps, 14 frames per second. All right, there you go. Great. Now can you see at the terminal at the bottom, guys? If you can see on the terminal, it shows what object ID it is, the class. It shows the class, right? One second, let me just pull the ID on the top so that you guys can see that. Give me a second. Yeah, I'm just trying to, there you go. Can you see it shows as person? If you can see here, see it's just detecting me as a person. And then let me show, say, keyboard. Let me just show the keyboard to the camera. There you go, it shows as a keyboard. Fantastic. So against each and every object it detects, it shows the class ID and the location and the time, right, with the local machine time. So can you see that? Good. So we are successfully able to execute the object detection. Now what next? The most interesting aspect is, guys, we have to now set a bounding box, right? That's going to be more interesting, and we need to modify our code little bit, not much, slightly. So right now what I showed you is a very basic object detection using a existing neural network. All right, now what I will show you is, in the next video I am going to show you how to actually recognize an object in a bounding box and with the name and the timestamp tagged on the bounding box itself. So that's going to be pretty interesting. For example, you take your camera to any environment. It can be a forest, it can be a building, it can be inside your house or anywhere. So the camera, whatever the object it sees, it detects and throws the image out. It processes through your neural network, and it will form a window with a set of strings which will basically populate a text, right? The detected text on the window, and also a timestamp, what particular time this has been captured. So imagine, guys, that there are endless possibilities with this, right? So tons of possibilities using this application with this particular neural network. You can do tons of things in Jetson Nano for robotics and artificial intelligence. All right, guys, that's it for the day, and I hope you enjoyed this. I'm going to leave the commands and the code in the description below, or I will also put in my GitHub link where I have these codes stored in there, so you can straight away go there and try to fiddle around and play around. All right, guys, have a great day, and do give me a thumbs up. I'm going to be back soon with the next lesson, how to put a bounding boxes, right? That's your object recognition. Bye bye.